film introduces the fundamentals of that part of air traffic control known as approach control. The approach control is provided for aircraft flying in or near clouds or in poor visibility in accordance with instrument flight rules. These are referred to as IFR flights. The purpose of air traffic control is to prevent collision between aircraft and to expedite and maintain an orderly flow of air traffic. Approach control covers the let-down and climb-out maneuvers associated with the arrival or departure of IFR flights. Three basic requirements must be met in order to accomplish approach control. Firstly, there must be a radio navigation aid for the use of aircraft flying towards or away from the aerodrome. This aid must be of such a type that it will enable pilots to identify a designated point in space near the aerodrome and to maintain flight in the vicinity of this point. Secondly, to prevent uncontrolled aircraft from impairing the safety of aircraft under approach control, an airspace must be reserved for the use of the IFR flights. This is called a controlled airspace. Thirdly, there must be radio facilities which permit direct two-way communication of the necessary information between the pilots of aircraft in flight and an approach controller on the ground. Approach control is generally provided by an approach controller in an aerodrome control tower. Sometimes it is provided by an approach controller in an area control center during the first part of the approach, and then by an approach controller in an aerodrome control tower during the later stages of the approach. In still other cases, the entire approach control service may be provided by a controller operating from a control room equipped with radar scope displays. This room is usually adjacent to or just beneath the aerodrome control tower. Besides being in constant communication with pilots, the approach controller works in close cooperation at all times with the area and aerodrome controllers. The necessary coordination between the approach controller and the area and aerodrome controllers is made possible by the rapid exchange of control information by landline interphone, telephone, and teletype systems, and by radio communication networks. The responsibility of approach control does not generally extend from the aerodrome in every direction in an unlimited way. When an aerodrome offers approach control service, a controlled airspace at the aerodrome must be defined. This controlled airspace must contain the let-down and landing paths and the take-off and climb-out paths of the IFR flights provided with approach control. The controlled airspace is generally made up of two parts: a control zone, which extends from the ground up, and a control area, which extends upwards from a specified height above the ground or water. The control area is required as it is usually necessary to protect IFR flights over a wider area than the immediate vicinity of the aerodrome. The provision of a control area above a control zone permits a reduction in the size of the control zone near the ground. This reduction in size is advisable since it allows uncontrolled visual flight rule, or VFR flights, to operate beneath the control area and around the control zone. In this non-controlled airspace, VFR flights will have adequate separation from aircraft flying in accordance with instrument flight rules inside the controlled airspace. Geographical factors must also be considered. Irregular terrain may necessitate the designation of control areas and control zones of special shapes and sizes. When the terrain near an aerodrome rises, it is necessary to raise the lower limit of the control area. This means that the size of the protective control zone must be increased to accommodate the flight paths of IFR flights. A control area may cover the vicinity of one aerodrome or of a group of aerodromes in close proximity. In many parts of the world where there is constantly a high density of air traffic operating along the same routes, control areas may take the form of channels, and they are then called airways. Now, let us see how approach control works at international aerodromes where flights are arriving and departing every few minutes. Flights normally converge on these aerodromes by making use of many different kinds of navigational aids. A radio signal identifies what is called a holding point at or near the aerodrome. Aircraft using approach control proceed to this point when approaching the aerodrome and then maintain flight in the vicinity of this point or proceed from this point only in accordance with air traffic control instructions. In this film, we will show how approach control operates during instrument weather conditions at an imaginary aerodrome which we will call Friendship International. Inbound IFR flights in this example are authorized by area control to proceed to Friendship Radio Range Station. Such an authorization is known as an air traffic control clearance. This particular clearance includes the name of the radio range station, the flight level, and the name and frequency of the approach control which the pilot is to contact to obtain further instructions. Transfer of responsibility for control from area control to approach control takes place when an aircraft reaches the range station, the clearance limit given by area control. Normally, pilots will contact approach control for further instructions prior to reaching the clearance limit, and they will give their flight level and estimated time of arrival at the range station. The volume of traffic approaching Friendship International is such that an approach sequence must be set up to hold some of the aircraft while others are landing. The approach sequence is the order in which two or more aircraft are authorized to approach to land at the aerodrome. Based on information relayed to him by the area controller concerning the numbers and types, times and levels of aircraft being cleared to the range station, the approach controller sets up the approach sequence. When pilots contact the approach controller on the approach control frequency, the controller clears them to take positions at specified levels in the approach sequence at a holding point and instructs them to follow a specific approach procedure to the aerodrome. The holding point and the approach procedure are determined by the navigational aids available at the aerodrome and in the aircraft. The navigational aid shown in use at Friendship International is the Instrument Landing System, or ILS. Each pilot reports to the approach controller his time and level when arriving over the outer marker, the holding point for the approach sequence. The approach controller gives pilots a runway number and essential weather information regarding visibility, ceiling, surface wind, altimeter setting, and any abnormal weather conditions. Normally, the plane which will reach the outer marker first is assigned to the lowest level from which the final approach to the aerodrome can be made. If two aircraft arrive at the outer marker at the same time, the one at the lower level is placed in position to land first. Successive aircraft are stacked vertically above aircraft number 1. They are cleared to follow a standard holding pattern at specified levels, one above the other, which will leave adequate separation between them. Each pilot in the stack or approach sequence is given advance notice as to the estimated time he will be instructed to leave the holding point on final approach to the aerodrome. These times are known as the expected approach times, and they are calculated to provide the necessary time intervals between aircraft leaving the holding stack on final approach. The lowest aircraft in the sequence begins its approach to land at the expected approach time given. The pilot reports to the approach controller on leaving the holding point and vacating his originally assigned level. The approach controller acknowledges this report. The next aircraft in the sequence is now cleared to descend to the level vacated by aircraft number 1, and the pilot of aircraft number 2 reports to the approach controller on leaving his previously assigned level. Each aircraft in the approach sequence is cleared successively to descend to lower levels in the sequence as these levels are vacated. Any delay in the final approach of an aircraft necessitates a revision in the expected approach times of every other aircraft above it in the approach sequence. When a pilot reports leaving the lowest level at the outer marker on his approach to land, the approach controller clears the aircraft to land, repeats the number of the runway on which he is to land, and any pertinent wind information. The pilot maintains contact with the approach controller until a landing is assured. At this point, the pilot is generally instructed by the approach controller to contact the aerodrome controller on a ground control frequency. The aerodrome controller issues the necessary taxiing instructions on this ground control frequency. In the event that an aircraft on its approach to land cannot for any reason actually land, it will climb to a specified missed approach level on a heading which is in accordance with missed approach procedures. The pilot will then contact the approach controller for further instructions. Missed approach procedures are published for every aerodrome. Approach control provided for departing IFR flights operates in the main in the same way as it does for arriving IFR flights. It is, of course, in reverse. Departing aircraft are given all necessary takeoff information by an aerodrome controller. This information includes taxi instructions, wind direction and speed, time check, altimeter setting, and runway number. Area control, approach control, and aerodrome control work together to coordinate the departure of IFR flights and issue a control clearance to each aircraft prior to takeoff. This clearance specifies climb-out procedures and cruising levels which will provide adequate separation from other IFR traffic. At the precise moment the wheels of a departing aircraft leave the ground, the time off is relayed to area control. The approach controller will generally control the departing aircraft during its climb-out maneuvers to prevent all possibility of confliction between departing and arriving flights. The area controller is mainly concerned with the protection of departing IFR flights after they have reached their cruising levels, including the possible confliction of departing aircraft with en route traffic. The transfer of control from approach control to area control may take place at an agreed time during the climb or when the aircraft reaches a specified reporting point. The exact time or place is coordinated between area and approach control. Now let us go back and follow an aircraft as it proceeds to make a landing at Friendship International using approach control service. This flight is United 162. Area control, through the facilities of the appropriate radio communications station, clears United 162 to the Friendship International radio range station at 6,000 feet, instructs the pilot to maintain 6,000 feet, and contact the Friendship approach controller on the approach control frequency. United 162 follows the beam of the radio range towards the range station in accordance with the clearance, and the pilot reports to the approach controller his flight level and estimated time of arrival over the Friendship range station.
United 162, this is Friendship approach, estimating the range station at 1314 at 6,000, clear to Friendship ILS outer marker. Descend to 5,000 feet after passing Friendship range. Maintain 5,000 feet. Standard 2-minute holding pattern. Report leaving 6,000 feet and the range station. Expect approach clearance at 1325. Over.
United 162, leaving the range station at 1315. Vacating 6,000 feet now. Over.
United 162, roger. Vacating 6,000 feet at 1315. Out.
United 162 approaches the outer marker. As it does so, lower levels in the approach sequence at the outer marker are being vacated.
Friendship approach. This is United 162. Outer marker at 5,000 feet at 1317. Over.
United 162, descend immediately to 4,000 feet. Maintain 4,000 feet. Report leaving 5,000 feet. Over.
United 162 descends to 4,000 feet and reports vacating 5,000 feet to the approach controller. As soon as the next lower level is vacated, the approach controller contacts the pilot.
United 162, descend immediately to 3,000 feet. Report leaving 4,000 feet. Over.
United 162, leaving 4,000 feet now. Over.
United 162, this is Friendship approach. Expect approach clearance at 1329er. Maintain 3,000 feet until further advised. Over.
The expected approach time has been changed from 1325 to 1329. United 162 is being delayed.
6,000. Depart runway 1.
Any one of a number of things may be causing this delay. A missed approach, mechanical difficulties occurring in an aircraft beneath it, or with a departing aircraft, or obstructions on the runway, and so on.
United 162, this is Friendship approach. Descend immediately to 2,000 feet. Maintain 2,000 feet. Leave outer marker on straight-in approach to land at 1330. Report leaving 3,000 feet. Time 1325. Altimeter 30.02. Visibility at field 1.5 nautical miles. Wind northeast 10 knots. Over.
United 162 starts to descend to 2,000 feet and reports to approach control.
United 162, roger, leaving 3,000 feet, 1325. Over.
United 162 descends to 2,000 feet, and the pilot plans his flight pattern so that the aircraft will be in a position to leave the outer marker on a straight-in approach at his expected approach time without having to perform any unusual maneuvers. As soon as the aircraft in front of United 162 is sighted by the approach controller and landing is assured, the approach controller contacts United 162 as follows.
United 162, cleared to land, straight in approach, wind northeast, 10 knots, runway 4, over.
United 162 starts its straight-in approach to the aerodrome and reports to the approach controller.
United 162, leaving the outer marker and 2,000 feet at 1330, over.
The pilot of United 162 maintains the aircraft's alignment with the runway during the descent by reference to the aircraft's instruments and the ILS cross-pointer indicator. When he is able to land by visual reference to the aerodrome itself or to the approach and runway lights, he is normally transferred to the aerodrome controller on the aerodrome control frequency.
Ground in sight, taking over for straight-in landing.
United 162, cleared to aerodrome control on 118.9 megacycles, over.
Approach control plays a very important part in establishing safety and regularity for aircraft making instrument flights. By expediting landing and takeoff, it minimizes delays to arriving and departing aircraft.
Runway 4, over.
For the service to operate smoothly, both pilots and approach controllers must have a clear understanding of the fundamentals of approach control.